We have an exciting topic today, using GenAI to find insights from your corpus and exploration of techniques. My name is Abrar Manzar. I'll be moderating this session today. We have today with us Josh Eckroth. He's a PhD and Chief Research Engineer formerly Chief Architect at I2K Connect, where he leads research efforts towards new AI-driven solutions. He holds a doctorate in AI and cognitive science from the Ohio State University. And he's former endowed chair and tenured professor of computer science at the Stetson University, where he now serves as a research scientist. So I'll hand it over to Josh. In the meantime, you can post your questions in the chat. And at the end of the session, we can have a Q&A session. I will also post a link for the webinar feedback at the end. So we'll be happy to hear from you, any feedback on this webinar and any ideas for any future webinars that you would like to hear from. So with that, I'll hand it over to Josh.
Thank you. Yeah, thanks for the introduction. I was pleased to see this opportunity to give a presentation like this because, using generative AI and particularly using your corpus of knowledge, which is not going to be part of the models that you get in the cloud, from OpenAI or Anthropic, it's your private data. That's definitely a need. And it's very interesting to see how to address that need. I think there's lessons being learned that are completely novel lessons. This is not a tech that we've had before. So there's a lot to figure out and techniques that are not working and techniques that are working. So I wanted to kind of show you what we've learned so far. So our goals for today are to first identify some of the workflows that use GenAI for finding insights. These will be in the form of like flowcharts, a sequence of events that the automation has to do. We're going to focus on specifically search techniques because search is, as you'll see, kind of the most important part of this workflow, of any workflow. If it's about your private corpus of stuff, you had better be able to find the things in it that are relevant. I mean, the LLM can only do so much for you at that point. You've probably heard of RAG, Retrieval Augmented Generation. This is a common technique, and so I'll show you that. And then slightly beyond RAG would be what people are calling agentic workflows, where there's like a variety of specialized tools or agents that do certain kinds of tasks, and they kind of enhance the idea of RAG. And then I'm going to just discuss some things from the field, from observing, building these kinds of things, making them work in actual, sometimes large deployments. So fundamentally, you're going to involve an LLM. I mean, that's Gen AI, right? But there's other kinds of Gen AI like imagery and video. So we're just going to talk about LLMs here, which would just be language. So on the basic level, you might have a question and you can just pose it to an LLM. So you could just directly ask a Gen AI solution, what do you think of this question? And it would make an answer. So for example, we're going to focus on the Volv field in off-coast Norway for this because it's an open source data set that's realistic. So if you ask where is that field, then this is Claude 3.7. It says, it's in Norwegian North Sea, situated in the continental shelf, block 15.9, discovered in 1993 by Statoil, which is now Equinor, and so on and so forth. So this is a question that it can answer. It doesn't need to consult your corpus. Typically, you would probably not actually have a file in your corpus that says this, right? It's not like you're going to have Wikipedia stuck in there. So this is kind of like background knowledge that it's great the LLM is bringing, but of course it doesn't have access to the things that you only have access to. So this is a perfectly good use of an LLM, but definitely this is a limited use when your question is really about your own stuff. If you do ask something about your own stuff, then you're going to have a problem. So this is a question that we've used in the past for an experiment. What's the measured depth of this particular well, F12, on this particular day at this particular time. So naturally, Claude 3.7 doesn't have that knowledge. I guess I shouldn't say naturally. I don't know what they've trained on, obviously, nobody does. But they could have trained on this data set because, I mean, I guess, I don't know about the licensing, but it is obtainable. So anyway, it says I don't know anything about that. And it says if you're looking for it for professional purposes, it recommends these, common things. So clearly you're going to need a bigger workflow than just talking to the chatbot when your question is about something specific in your files. And in this case, it'd be like from a daily drilling report. So that's the point of this whole discussion. So what do you do? Well, the first thing you might consider doing is search, right? So you have this question and your goal is to use your actual corpus. There's probably the answer in your corpus. There's some file sitting somewhere amongst your terabytes of stuff that has that answer. So you're going to have to form, or not you, but the automation will have to form a search query from your question. And it will then have to feed that to the index of your corpus, because your corpus is going to be indexed for speed, right? You're going to have already processed or at least discovered all the files so that you know basically their titles, maybe a little summary of each file. So that assists with the search. And then the search will return some items. So search is one of the hardest parts because, if you do have terabytes and there's one answer in one file amongst hundreds of thousands or millions of files, how do you find that? And like I said, we'll use the Evolve corpus, which is about 25,000 files that document the operations from a particular date range in that field. If you look at the corpus, these are our classifications of it. So we've already pre-processed it and identified what are the general categories, or actually not general, specific categories in the case of logs for the files. And so this is just a kind of distribution. The ones we're going to be most interested in would be the daily reports, but there's a lot of logs too, which may be like binary formats often. Okay, so how do you do search? There's frankly, 40, 50 years of research in this. It used to be called information retrieval, IR, and it's not irrelevant, right? It's very relevant today, even though we have all this fancy new technology. So I'm going to talk about the techniques for doing this search. And you might feel at the front of it, like the front of this discussion, where's the GenAI coming in? And again, we have to focus on the search before we can start including that. Because if you're not feeding it the right stuff, it can't do anything. The search techniques can be broken down into sparse and dense. And you may not have heard these terms, but they're actually a very good description of what's actually happening. More likely, you've heard things like keyword and vector search. So sparse is really the keyword search. This is where you have specific keywords that you're looking for, and you're checking which files or which items in my corpus have those keywords as well. And they may not have all of them, but if they have more of them, that's better. And we call this sparse because in some sense, you can imagine the question as amongst all words, say in the language of your corpus, you're only looking for like 5 of the 100,000 of those words. So if you think of like a vector of ones and zeros, there's only 5 positions that have a 1 and the rest are zeros. So it's like a sparse vector, right? And you're checking how close does this vector match all the items in my corpus. So it'd be a sparse one. A dense vector is the other kind, which is where all the values in the vector are non-zero, probably. So this is what people normally call vector search. This is kind of the newer technique, right? Since LLMs came out like BERT, we've had embedding models, encoding models, and we use those to generate a vector for the question. So we take that question vector and then we compare it to the vector for every single thing in the corpus. So every item in your corpus, like every document, would have a vector also. And these vectors are typically normalized, so their magnitude is 1. And then you take your query vector, which is a single vector, and you take potentially all the item vectors from your corpus and match them and see which ones are the closest from that corpus. And you would do this with like a cosine similarity. So these vectors don't mean anything, not like a sparse vector with keywords. They're just a bunch of numbers, typically, up to 1,000 or 1,500. And you can make these by asking maybe OpenAI or asking a local model on your machine to compute a vector for this document's text. So we check that query vector with every item in the corpus's vector. And of course, there's efficient ways to do this. You're not really having to check everything. And that would give you a similarity match for that question and those items in your corpus. So now we have two approaches. One is, do you have the same words as my question, or at least mostly the same words? Second approach, do you match similarity? Do you have a similar, I guess you could say, meaning as the question? Like, does this item have the same meaning as the question? That's kind of what a dense vector search is doing. I'll show you examples of these, and everybody's kind of realizing you can't just do one or the other if you want the most performance. A hybrid is probably best, so that's where you do some sort of combination. Now, it's not easy to strictly combine these in some sort of like mathematical way, but you can do like a weighted combination where you could say you get some points for having a keyword match and you get some points for having a high similarity on the vector search, and then we kind of score you that way. So here's a question that we saw before: measure depth for this well on this day at this time. If you had the ideal keywords of these, you would actually get some great matches. Maybe some not so good ones too, but the first one, the highest scoring match, and so I'm using Solr for this, like I brought in all the documents and using Solr matching. So if you're familiar with this area, it's using TF-IDF or BM25 to kind of weight the keywords differently. But that file, the first one that I've underlined, is actually where we want to find the answer for this question. So that's a great match. It's the first one. The others potentially, they're probably not actually helpful, but all we really need is that first one. So it's perfect, right? Keywords did it. The problem is, this is the ideal keywords. Like, what would I type as a human? But given that long question, what's the measure depth for this well on this day at this time? Who's to say the time's not the thing that's the keyword, or the phrase measure depth, or using the word well, right? So those would actually distract and make you not get great results. So if we know exactly like what the keywords to use, maybe this is sufficient, but how do you get the keywords out of that question? And so one approach that people use is called KeyBERT. It's a trained model specifically for keyword identification. There's others as well, but this one in particular thought the keywords would be depth measured 12, 15, and June, which produces awful results. None of them are actually, at least the top 5, are not the day we want, and they're not even all about that well. So already we see there's something difficult here. The well name 15/9-F-12, you got to make sure you don't break that apart, right? And these models don't understand that. And so they break it apart and you get a 12 and you get a 15. And then June, maybe that's important, but really it's the whole date that's important. The time, it skipped the time, which is good. Depth is okay, measured, maybe. They're not always mentioned that way. It might be MMD, right? So the idea of using keywords, just because we have one example that works when we have the optimal keywords, doesn't mean you can automate this and have success in every case, right? So that's when it becomes tricky. Like, you don't know what they're going to ask and what the best ones are going to be for that question for your corpus, but you still have to automate it. Here's a different question. For this well, F1C, approximately how long will it be before operations are underway after the feasibility study is completed? If you knew the ideal keywords again, you would have the well name and the phrase feasibility study. You'd not say anything about approximately, how long, because the document's not going to talk about it like that. If you do use these ideal keywords, then you've got exactly the 2 files that you want. So again, here's a case of it can be done if you know exactly what to look for with just keywords. But Keybert, again, doesn't, I mean, it does better because the answers that we want is in the position 3, which is, you could work with that. But it chooses feasibility, underway, which is not really what the document's going to say, 15, which is completely irrelevant, long, and approximately, and so on. So again, you're kind of just hoping like this grab bag of words from the question somehow works. So we see that keywords, and people have had this experience where, okay, keywords aren't doing it because we can't reliably get the right ones. If somehow you just knew them like an oracle, then sure, they would work, but you don't know what the right ones were going to be for every question that people could ask. And so people have been looking for an alternative, right? So enter the dense vector. If you take all the items in the corpus and make a vector for them and then put that on a 2-dimensional plane, it looks like this for this particular corpus. This is using, I forgot the exact model for the embedding. It's the standard one from sentence transformers, like MPNet, something. But anyway, it would all kind of look like this depending on, kind of regardless of which embedding you use. So if you plot it in 2D, right, which is not really completely accurate because it has like 300 dimensions, but still you can kind of visualize it. Then you can see there are actually kind of groupings, and they're not terrible groupings. So I was poking around, like looking at the actual dots here and seeing what they were. And so I've highlighted some areas that I can recognize were kind of patterns. On the left, you have the well logs. I don't know if it's all the well logs, but it's certainly that collection is well logs. You have SegWi files on the top, daily drilling reports. The HTML, XML, and JSON versions are all collected, which is nice. We have standard survey reports, a little cluster there. So the idea is you're going to take your question from the user, and it will be somewhere in this space. Like it has a vector too, right? And it'll just, I don't know where it's going to be, but it will be somewhere. And then you would look at who's closest to me, and those would be your most similar documents. So if they're typing a question about well logs, you would hope it goes into the left side and somehow drops in there. Ideally, that's where the query vector would be. So the question is kind of how well does this actually work? A more deeper question, well, maybe not deeper, we'll look at how well it works in a moment, but a thing to know is with vector similarity, it really is about how these things are trained. They're not really trained like you would think keywords would be used. It's more of they're trained to overall get the meaning, the semantic meaning of the text. And so in that respect, different well names are semantically very similar because I can imagine all kinds of document titles and phrases and tables of data where the well name could be one thing or another, but the context is the same, right? It's a daily drilling report about well X. And so any well name could be in that position. And when it's trained, it will see a lot of examples of different well names. And so it will say, well, I guess all the well names are pretty much the same as far as their overall meaning. So they're going to actually appear close to each other in the vectors. And that's either a problem or it's not a problem, right? It's not a problem if all you care about is any of the wells, like show me something about any well. But if you care specifically about one well, like 15.9F1C, and the closest documents are about 15.9F5, that doesn't do you any good, right? So it's tricky to rely on vector similarity for questions that are very specific. And likewise for dates, there's other things we can look at too that are similar to this, but dates are going to be next to each other too, even though they're written in different formats, which is great, right? Because we don't really want to have to play with all the formats that date could be written for like a keyword search. But if you only use the vector search, then April 21st, 2010 is very close to July 25th, 2012. And you're getting documents from unrelated dates, even though you explicitly asked for one of those dates. So we would say that vectors are actually like they almost contrast with keywords because they almost explicitly don't use the exact phrasing that you provided. They're more beneficial if you're interested in synonyms and rephrasings and kind of other uses of language that have the same meaning. If you can take meaning to not be specifics about dates and wells, but just the overall gist of something. Like there's an interruption and we did a repair. I mean, that's a basic idea that a vector might match quite well, but for that specific well and date, it's not going to match very well. So they're kind of contrasting approaches, the keywords and the vectors. If you only use vectors, then you take this query and you make a vector for it, and you take all the items in the corpus and make a vector for them based on the title and the some of the text. Then this question about F12 on June 26th at 3:59 a.m. gives you documents like this as the top matches, where it's great they're daily drilling reports. I mean, actually, that's quite impressive, right? I didn't say anything about that in the question. But they're for different wells sometimes. They're definitely for different dates. And how many of these would the automation have to go through before it finds the one that it needs to find, right? So this is if you're doing pure vector search. And then for the other question, for well F1C, how long before well operations are underway after feasibility study is completed? There's a feasibility report for a different well in line 6, but this is not really doing anything for you. So actually this time it did final well reports often again. So vectors are tricky. Another choice, not everybody seems to talk about, but it's definitely helpful, is if you have filters or categories or classifications or metadata, right? If you can just immediately jump to a subspace of the corpus that is relevant to your question and throw away like 95% of the corpus that's never going to match this question. And you can do it with just if you can find a way to somehow take that question and identify, they've mentioned well F12, and they mentioned like, I have to think about the words that would be used, but if ideally you can hit daily drilling report as the filter, the type of report you're looking for, and you combine these two, do the intersection, you have the documents on the right, which now it's just a question of the day, right? So you've narrowed in on a very small subset of the corpus immediately. So if you do that, if you got these filters perfect, right, from this question, so maybe measured depth could be something that's used to kind of focus on daily drilling report. But anyway, if you knew to choose 159F12 as one of the filters and daily drilling report as the other filter, and then you just add this keyword, you have the singular document that answers this question. And in this other question, one thing that you can do is kind of inspect the question. So how long before well operations underway, feasibility study, and so on. It could suggest you might be thinking about well planning. I could use that filter for you, give me 46 documents. We can go further, and I see that you're mentioning a well. I can isolate that well. That gives you 2 documents. Turns out that's the right 2 for that question. You see on the right, this is like an auto suggestion kind of thing based on this question. And there's a lot of different formations this well goes through. So it is arbitrary which one I've chosen, but it narrows in on exactly the 2 files that we care about. So in summary of the search techniques, you have the sparse, which is keywords, kind of the traditional way. That can give you high precision because you're saying exactly this phrase should be in this file. And that's going to narrow in on files that have that phrase, right? But you may miss some important ones that had a slightly different phrase. A dense search would be for vector similarity, and that gives you a lot of stuff. Maybe it's irrelevant too. So you can potentially get all the things you might need plus extras, and your answer's in there somewhere, but it won't be as precise because it will handle like rephrasings. And then the filters can dramatically reduce the space that you have to even do keyword and vector search for if you can get the right filters. And of course, that depends on the filters actually, like if they're classifications, they're actually accurate to the items in your corpus. Suppose you have images, and you're identifying what's in the image using computer vision, that needs to be accurate if you're going to be able to trust the filter, right? But that's a huge savings to focus in on the right space. So hybrid would be some combination of these things, right? So I'm not going to get into details of techniques of that, but there's things that can be done there to use the right combination. Okay, so that was about finding the right items. You do a search of some technique or another, and you get to the right items, and then you can open them up and glance at them. But we all know GenAI can just answer directly. So why not do that, right? Why give people the documents if they ask for the answer, not the documents? So let's deliver the answer, not the items. To do that, the basic idea is just send those items to the LLM and don't show the answer until it's gone through that step. So replace what you had to do, the reading of all these matches, with the LLM doing that for you. Now, it's important, obviously, to have that arrow at the bottom of the diagram feed the original question to the LLM. Otherwise, you're just feeding it items, and it's like, what am I summarizing these? So you're going to have to give it the question that was asked as well. So as long as your search is producing items that are good, that potentially actually have that answer, then you feed those plus the query, and it should be able to produce the answer. This is RAG, right? Retrieval augmented generation. So the LLM is generating, but from what input? Stuff retrieved. We've learned, interestingly, LLMs are very good at reading, even all kinds of documents, like domain-specific documents, like daily drilling reports, tables and stuff. So if I go to ChatGPT and upload this file, which of course is like open source, ask the original question, but I give it the file, right? It's the perfect file. It has the answer. It's perfectly capable of reading it. And what's cool about this file is it doesn't actually mention 3:59 a.m. It just mentions other times. And so the LLM has to make has to do a little thinking about that to find which row in the table actually has that measurement or for that time. So if you can find the right things, the LLM can do the reading for you for the most part. Now, there are questions that go beyond give me the answer from a file, which we would call like needle and haystack search. So this is where, or the ones I've shown you before, are where one file will have that answer. But if you want to ask questions that require looking at multiple files to produce the actual answer, then you're going to need a bit more, generally speaking. I mean, you might get lucky and it can work in the first pass, but you might actually have to do a few iterations in the automation. So this would be the agentic approach. Now, agentic is sort of a fancy word. It just means there is like a loop where the LLM is actually deciding which agents, also called tools or just functions, right? They're just programming functions that should be run to help it along the way. And it constantly reevaluates what comes out. So our previous workflow of query goes to search, goes to items, goes to LLM is still in here. And maybe that will be what occurs. But first, the LLM will look at the question and decide what to do. It may decide to do a search right away. I mean, frankly, it may decide to just answer you, not do anything else. If it's like, where's the full field? You can just answer that. But if it believes it needs to do a search because it has no items to refer to yet, then it will ask the search agent, can you please do this search? And potentially it will feed it, which keywords or the question. The search will occur. Some items will come out, hopefully not too many, hopefully not thousands, right? Because then they have to go back to the LLM and be considered. So I've got an example here, different question. What issues have been reported with flow line isolation valves? What was the average interruption time? So this is going to be across multiple daily reports. And one would be looking for things like, obviously, flow line isolation valve, interruption, and so forth. So the LLM will have to, this whole workflow will have to find these different files and start collecting them to make an overall answer. So the process would be the LLM first takes the question as posed, what issues have been reported, and so forth. And it says, what do I think about this? Can I answer this directly, or do I need to do something first? And of course, we have a prompt that guides it. Our prompt says, typically you're going to want to search first if you think you can't answer this question directly, and so on. So it says, yes, I'm going to do a search. And it searches, we actually have it come up with the phrase to search. Searches for flow line isolation valves, issues reported, average interruption time. It rewrites the phrase just in case the question had all sorts of extra stuff in it, like how the person wants the answer formatted or whatever. So that stuff kind of gets stripped out. So the search agent is just the previous search functionality. It does keyword extraction, figures out the right filters, does a vector match, and overall does a hybrid thing. In this case, 11 documents came back, which are daily journaling reports from various days, from various wells, frankly. They presumably mentioned something about flow line isolation valves. So those items get sent back to the LLM, which then looks at those and says, what do I think about this? And we have another agent that evaluates the relevance of a document for the question. So the planner says, for these documents, I'm going to send maybe all of them or most of them to the evaluate agent to figure out, maybe from the first page of text and the metadata and the title, does this look like it's actually going to be relevant for the question? Because the search gave it to me, but that doesn't necessarily mean this is what I want to use. So then it evaluates them and it selects 5 that it wants to look more closely at. So then it sends those 5 to the summarize agent, which is, again, given the question of, what's it trying to answer? And then it pulls out the facts from the documents and makes like a kind of quick, short, this is what you need to know kind of thing for each of those 5 documents regarding flow line isolation valves and interruptions. So then those get collected and the LLM planner at the top says, okay, now I've got what I need. I can actually produce an answer. So that workflow, there's loops, but it's not too complicated. We have learned, though, that there's an interesting phenomenon here. If the items that come out from the search agent are not sufficient, or there's just none, right? Just can't find anything, the LLM at the top, the planner, just an LLM, really has no way to know if its search agent did the right thing. There could literally be no answers in the corpus, or there could just be a bad search. It has no way to tell the difference. So that's an interesting phenomenon. It doesn't know your corpus, right? There's way too much stuff for you to tell the LLM, here's all the stuff that exists. So you have to do a search based on the question. And if that search is poor, and the LLM gets poorer results, it'll just say, I don't know, there's no answer, but there maybe was. Now here's the actual response for this demo question. And there's a lot of details, a lot of references and so on, so you can go look at the original documents and it makes a calculation at the end. So fair enough. The workflow appears to work. For this particular response, well, actually, if it's just a straight question, Q&A question where it doesn't need to do search and all that jazz, you would get obviously a few seconds per response, right? We're all familiar with that from something like ChatGPT or Claude. For this kind of workflow, it could get into 10 to 15 seconds because it has to do all the searching and evaluation and summarization. But those steps are pretty much, they're very important. It's hard to skip those steps, particularly when you have a large corpus. The cost of all this, and this was GPT-4o mini in this case, was half a cent. So I think that's pretty good. The cost and the time will decrease over time as the new models are released. So that's constantly improving. And then if you do want to use a model on premise, like a Llama model, for example, then you don't have to pay those fees for the tokens. As far as how fast it will be and all that, it depends on what kind of hardware you're able to run it on. Some of you might be wondering about things like DeepSeek in O1 and O3. These are models that do a lot more reasoning before they come to a conclusion. So potentially this kind of model can make better decisions about the agents, like what tools to run in which order, right? Because it thinks harder about it. Potentially it can understand more complex items in your corpus. If you have files that have a difficult language, or there's just a lot of facts in that file, one of these models may do a better job of writing a little summary for the user's question. Potentially, it can make more advanced conclusions, like it can use logic to look at all these bits of evidence from the corpus in your question and then make a more advanced conclusion from that. I just asked it for an average number, but if you asked it for something harder, potentially these models can do a lot more reasoning and using the evidence from your corpus. Now, they do take longer because they're doing a lot more generation, even if you don't see it. So that's tokens that you're going to have to pay for, and it's time. They still don't know your private corpus, I presume. So you still need some sort of workflow that captures the right items in your corpus for this question, right? That's the whole search process. All right, so what's next? Well, we've sort of seen that there are different kinds of questions. Some are harder than others. So if you have a question for your corpus, like, is there any evidence of something occurring, ever using this controller model XYZ? The workflow I just showed is pretty good, right? It'll find some examples. Maybe there are thousands of examples across your corpus, but if it finds some, it's technically answering your question. If your question is instead of what's all the evidence that we've used, which PLC models for use in a blowout prevention, then you have to be sure the automation is finding every true item in your corpus. Like, it can't miss any, because that was exactly your question. Give me all of them. And we've seen a lot of scenarios where people actually want to use this workflow and they want to know it got everything. I mean, that is perhaps the person's task, is to find all the occurrences of X, and this workflow makes that somewhat challenging. There could be a lot of documents to examine, like thousands or more, and obviously you can't feed them all to the LLM. You can get very long response times as it's doing its job. You can easily explode through the limit of the LLM of how much it can consider. So if you think about deep research and similar tools, they start to solve this problem. And here I've asked, it doesn't know anybody's private corpus, but I've asked find all PLCs that have been used by the blowout prevention. And it's doing web searches, so it's finding stuff on the internet about this. But it took 7 minutes and it has 33 sources. Now, I have no idea if this is exhaustive, right? It probably is not. I don't see how it could be. This is a good report for a starting point. Like, tell me some that are used for this purpose, but there's no way that it would be able to convince me that it's all of them. So it's a good way to get insight to a question, but insufficient to get a complete answer, this kind of approach. So what to handle these more complex questions, you're going to need a different kind of workflow, or at least apply the workflow a little bit differently. And this is pretty much the end of the presentation. If you have a system that's 100% accurate, like suppose deep research was 100% accurate and complete, it can be slow. That's fine. And I don't have to adjust how it's behaving. I can just believe the result. But of course, that's never going to exist, because you would have to be able to read minds. Like, what if I phrase my question slightly incorrectly or whatever? So that's just not, you can't have a 100% accurate system like that. That's completely automated. If the system is very fast, you always get like quick response times. It can actually be moderately accurate as long as people know what to do next, what to adjust. They can see the answer quickly and say, oh, I should try this instead. And we all have done this naturally. Every time we use tools, we naturally learn how to use them. So like Google, for example, I mean, we've all learned how to make Google queries that work better. And of course, if the tool changes along the way, then we have to keep relearning. So that's difficult. But if you give fast responses, people will be encouraged to try something else, try the next thing, and they'll gradually learn it. If the system is fully automated, you can't adjust it at all. It's kind of the inverse of the first one. Sure, it can be slow, because I mean, you can't do anything anyway. You can't adjust its behavior anyway. You just have to wait. But then it has to be accurate, because you have no ability to control it. So in the middle is what we're really targeting. So we want to decompose that agentic workflow into more interactive, break apart the steps that were being done automatically and let the user control those steps. This would be maybe known as situational awareness and agency, right? Let the user know what the automation was going to do, or its choices, its options. Let the user decide if that's appropriate, and then it proceeds to the next step. And maybe they can even adjust exactly what it's about to do. So that gives them agency, and it gives quick responses, and then they can learn how to use the system. So this is actually known as handoff in task automation. It's the same with autopilot in planes. It's, in cars. At some point, you have to assume there's going to be some point at some moment when the human has to take over. And the critical aspect of that handoff is that the human knows what's happening and knows what to do when that takeover occurs. So it has the appropriate situational awareness. And so we're trying to find a way to make those workflows that do all the searching and the summarizing provide situational awareness to the user so they can influence those steps. We might call it a virtual team member. So in summary, GenAI does support finding insights in your corpus, in particular things like RAG and use of agents, which in what I showed you was agents like search, evaluation, and summarization. Accurate search is critical because the LLM has no idea if that search was simply broken or truly there are no answers in the corpus, right? Search is best done with a hybrid of keywords, vectors, and filters, because if we look at each individually, we're not doing as well as we could if we combine them. And the next steps are reduce response times and enable closer collaboration to make more of a virtual team member. That's everything. So I want to open it up to questions now.
Josh, thank you so much. That was a great presentation. We do have some questions in the chat. Are you able to see the chat?
I do see them. Okay, I'll go in order. First question is, will a copy of the slides be available? Yeah, I'm happy to do that.
So we'll coordinate with you, and
yeah.
maybe you can post it on the YouTube channel together with the video.
Okay, add a link to it, yeah.
Yeah.
Is Llama Index or FICE better to use on my data set? Interesting question. So to compare these two, Llama Index is a whole kind of platform that can accept the query, can accept a whole set of files, makes the embeddings, and allows you to provide the query and get the matching documents. It's also like API, so you can use it with your own Python code. As far as FICE, that is very specifically the vector matching step. I believe Llama Index can probably use FICE. So FICE is a library from Facebook AI, if I remember correctly, that does just the vector matching. And when you have 100,000, million, 10 million items that each have a single vector, right? That's a lot of vectors. And to quickly find the closest vector, FICE uses various techniques that are like it organizes a hierarchy of the vectors so it can jump to a space close to your vector very quickly and then search amongst there. So FICE is specifically to optimize that step. It doesn't really do much it doesn't do anything as far as indexing your files or handling your queries or doing GenAI and that kind of thing. So if you're going to want like something that's more off the shelf, I would go with Llama Index. And the rest are regarding the recording and so forth. So
yeah, Josh, we also have some additional questions in the chat if you're able to open that.
I see. Okay, I have open.
Yeah, great. There you go.
We go to the top here. What trade-offs do you consider between off-the-shelf embedding like OpenAI's text embedding 3 large versus fine-tuning an embedding model? What's your go-to? What about for retrieval? Okay, so let me just describe a little bit what you might get out of training your own embedding model. So first of all, if you think about it, the goal of this step right here, the goal of that is to make your question match closely the items that should answer that question. And so what that actually means is if your question is 5 words or even a sentence, and your documents are massive long documents, or maybe you've broken it by page, so, but still, it's a lot of text. Your goal with an embedding is actually to make whatever the model is, the vector for that question be very similar to the vector for that long document, which are two very different things, right? First of all, your question is probably phrased like a question, or it's just a list of words, like keywords. And the document is whatever, it's in prose, it's got tables, all sorts of stuff. So how do you make a model that puts them on top of each other? Two very different kinds of things. So if you only train a model to put, I mean, I guess my goal is, my point is, you always need a model to be trained for a particular purpose. And in this case, the purpose is to make a query match the item that should match that query. So the vectors need to be similar. So you have to train it with example queries and the best matching document, right? So you get all the vectors for the queries and you get all the vectors for the documents, and then you train it to change those vectors so that they essentially overlap at just the right times. And then it's typically, you're also simultaneously training it to not match anything that it shouldn't match. It like pushes those away as well. So in that respect, you can get benefits from explicitly training on your data set, but you'd have to make such a data set. So the data set would be things like, here's realistic queries, and here are actual documents, and I need that query to match that document, this query to match that document. That's your training set. So that can be done. We've done some of this as well, and we found that we do actually match better. It was incremental, it wasn't like twice as good or something, but you can do better. Comparing your options that are off the shelf right now, the ones from Microsoft, IntFloat, E5, those are pretty good. And there's ones that start with BGE, those are pretty good as well. That's just for kind of general purpose. And then, so those you can run on your machine. And then there's ones in the cloud, like Cohere has embeddings, and then OpenAI has text embedding 3 large, for example. And these, you would pay a very small amount for every embedding that you get, right? So you can do all your documents ahead of time, and then you have to do every query as it comes in. But they're very cheap compared to generating text. The way you can actually think of it is an embedding essentially produces a single token, a single word. So it's like you're generating an answer from ChatGPT, and it's just the first word you care about, and you stop after that. You've only paid for that one word. So that's what an embedding would be. Text embedding 3 large is very accurate. So if I were to use a cloud one, I would use that. There's another one called Nomic that has a property similar to OpenAI's. That property is called Matryoshka embedding. It's that Russian word. The point is, it makes an embedding of like 1,500 dimensions, but you can chop it at, say, 300 or whatever you care about, and it would still pretty closely match. So you get to decide the size of it, which can be important if you're trying to conserve space. Okay, there's a question, have you used dictionaries in the handling of clusters of words? For example, we search for word color and get these various colors. I haven't checked on that kind of case. I believe the embeddings that are off the shelf will mostly do that. If you take color as the query and the actual colors as the matching items, you might get good results, but I've not actually checked that specific case or any case that's kind of like that, like word definition or word plus examples. That would be an interesting thing to check. Someone says, at the end of the day, asking the right prompt engineering question can make a huge difference. Yes, so clearly there's some prompts in this process whenever you're using GenAI, and those can be better or worse for sure. Even as the models change, you get O1, O3, and these things coming out, your prompts have to change too. So that's always something to keep up with. But what's interesting about that is, like I said in the last slides, you do want to give people the ability to influence that, because they can learn too, right? They can learn, oh, if I tell it to list all the options and then I tell it to evaluate the first 5, it works better than just asking it in a single shot. right? So I'm not against the idea of people having to sort of learn. I mean, we can train them as well, but learn the best way to use a system, because that's maybe the most reliable way to get the best results. So I think the prompt engineering is internal as well as it's people learning how to use the system most effectively. Someone asked, when implementing chatbots, which multi-agent platform would you use Crew AI, but has a lot of difficult reading even simple text files? So at I2K, we do have like a whole platform for the processing of the files, and we have a kind of customization of this agentic workflow. But for something that is a good way to get started, LangGraph, which uses LangChain, is a pretty good framework. When implementing chatbots, how does DeepSeek handle semantic search challenges such as identifying synonyms? Does it rely solely on embeddings? I'm not sure exactly how they do it. It's probably similar to what I've shown. So that would be what my answer is there. I'm not exactly sure. Finally, do you have any recommended strategies for evaluating precision accuracy responses at scale? Yeah, well, that is definitely difficult. So you can certainly make a collection of your ideal scenarios, right? You want this to match that and not to match these other things. And you can certainly automate the testing of those. But in practice, once it's deployed, it is challenging to know for the new questions if people are getting the right answer. And so we're actually thinking pretty deeply about this. We have some experiments that are about to get going here with exactly this kind of framework. And there are things like mining the logs to see, are people trying variations of their question, right? You can use an LLM to find this kind of thing. You can say, here's the history of conversations. How often are people rephrasing and trying another, but it's the same question? You know, apparently they're having troubles. You can also see how often the search is not producing anything and the LLM just says, I don't know. Beyond that, you can do things like ask for their feedback, like, was this response helpful? You can do the thing like A/B testing you might have seen on ChatGPT, where it gives you two responses simultaneously and they pick one. We are doing an experiment for a custom-built LLM where we're showing two answers and they're choosing which one they prefer. So things like that. But it is challenging because once it's deployed, you don't know what people are asking. And in particular, I mean, you know, but you don't know ahead of time. In particular, the corpus is probably changing too. So as new files come in and some disappear, the answers inevitably change. And so you can't necessarily say, I always want this one question to have this one answer, because that may actually change over time. I guess there's one more question. Did this demo use a fine-tuned model or standard version of a model? This demo used a standard version. So the embedding was standard, and then I used GPT-4o Mini for the question answering example. Okay, I think that's
Yeah,
time.
that brings us to the top of the hour as well. So thank you so much, Josh. Really appreciate your time and talking to us. And for all the attendees, I've also pasted a feedback form link there. Please take a moment to provide us your feedback. Also, any suggestions for the future webinars, you know, topics, speakers that you would like to hear from, we'll try to make that happen. So I do appreciate everyone's time today. Thank you so much, and goodbye until the next time. Take care.
Thank you.